As Olena already introduced me, my name is Vlad. I'm a .NET automation tech lead at Ciklum. I have about 7 years experience as both a developer and automation engineer. I've been creating multiple frameworks, both in C#, mainly in C#, but also Python. I'm 2 years with Ciklum, and I'm very happy to be here. So today we're going to talk about the topic, which you probably know. This will be how to avoid common mistakes in test automation and get the most value from your automation project. And the agenda today will look as follows. So first of all, we're going to start with the basics. Why should we automate at all, and how can we choose what we need to automate? Then we're going to talk about why focusing on progressive tests is more valuable than covering regression, which is the classic approach I see in the projects. Also, we're going to discuss why it is important to involve developers in your automation tests, how to make sure that your tests are properly isolated, why you should invest in very good logging for your tests, how to deal with flaky tests and keep the test pipeline always green. Also, why you shouldn't just ignore your test cases when there are some defects or there are some issues open. And at the very end, we're going to talk about speeding up your tests and using such approaches such as parallelization, using API in your UI tests, and, for example, Selenium Grid or Selenoid. So I will try to keep this presentation not very technical, so people from different languages and backgrounds can understand it, and it should be useful for all of you. Of course, I'll try to keep it interesting. If you have any questions, please keep them till the end, and then we're going to have a Q&A session, and I'll try to answer all of your questions. Okay, so let's go on. So first of all, starting with the basics, choosing what we should automate and why do we automate at all. So most of you probably know that the main reason why we automate, this is done to reduce the costs of software development. This is usually the main motivation of many things we do in software development. First of all, it allows us to reduce the amount of manual testing which is needed, and this allows us to release our software much faster because, of course, automated tests are much more faster and they are very cheap to execute. They don't require human intervention. Also, it allows you to add new features or do the refactoring on your code very easily because you have a kind of a safety net of automation tests. And once you introduce some changes, you get very quick feedback, like, for example, if something is broken. So this is another very important benefit of your automation. So not only it reduces the amount of manual testing required, but also it allows you to cheaply introduce new features and do refactorings with much more confidence than without it. So how should we choose what we should automate? So let's imagine we come into a project where automation wasn't being done from the start, and we need to figure out what we should start from. So we have, for example, some application. So there are several criteria which you can use. First of all, this should be the business value for given component of functionality. So we need to take into account how valuable a given application area or a feature is to the business or to the end user. But that's not the only thing. Also, we need to think and figure out how often is this functionality changing, and is it being under active development. So there could be cases where, for example, there's a very stable part of application which hasn't changed in several years. There are not many bugs there, and there's not too many value introducing automation there because we're not expecting it to change. And also the third thing is to think about where most bugs are reported. So usually this hints you which area of application will benefit the most, because these bugs would be found by automation much quicker than by regular manual testing. So taking this all into consideration, usually most automation projects, they start from a so-called sanity suite, or sometimes people call it smoke testing suite. There's a difference between them, but I won't go into too much detail. But basically, this is a set of tests which verify the very basic flow of application and the most important business flow. Usually, this is some kind of a happy path which touches most application areas. So this is non-controversial. Usually, you should pretty much, most of the time, you should start from such set of tests. But then it comes the interesting part. So what to do next? Where should we focus next? And there are two main approaches after covering the sanity or smoke suite. So first of them is covering the regression. So this is writing tests for functionality which is already developed. This is the most common approach I see, unfortunately. And another approach is so-called progressive tests. So these are the tests which are written for functionality which is currently under active development. And now we're going to talk about why progressive testing is much more valuable, in my opinion. So before we move on to progressive tests, let's talk about why the standard approach of working on regression is less optimal. So first of all, development never stands still. So usually test managers, when they think about this, they think, oh, we're going to start covering regression, then we're going to be done at some point. And then once we cover this regression, we're going to move back, we're going to catch up with development, and then we're going to try to write tests for features which are under development. But usually it never happens because development process never stands still. And more features are added, and we'll never really catch up. So this is like, you can imagine a hamster running inside a wheel, which never catches up with this goal. So this is how it usually looks like. Also, you have to ask yourself, where do you expect to find most bugs? So is it the areas of application which are currently being changed and modified, or are these areas which are already released and tested manually? So usually, I think the answer is the parts of application which are being currently worked on. Also, usually when we start working on regression, we start automating manual test cases for some old functionality. And those manual test cases are usually written quite poorly because they're written for the humans, not for the automation test. So we have to go back to those test cases. We need to understand them. We may ask QAs about them. We need to ask them questions, etc. So this is not very optimal. And also, there can be a situation where, for example, some application area is not very suitable for automation. For example, some automation IDs are missing if we're talking about UI tests. And if this feature was already released before, we have to ask the developer to go back to it and, for example, add automation IDs. And this requires some context switching. Sorry, I can hear someone is not muted. Can you please mute? I can hear some noises. Thank you. Yeah, and the last but not least, this is a lack of good teamwork between developers and AQAs. So this is a very important thing, which is very often neglected, fortunately. When people are working on different things, so for example, developers are working on some features in the current sprint, and we're working on completely something else, we don't usually interact very much. We might talk with developers when we find some bug or we have a question, but there's not really a feeling of a good teamwork because we're working on regression, they're working on current functionality, and we don't really have a team. We're kind of a part of the same team, but usually it looks like an island of automation testers, which is separate from the rest of the team. And this way, the teamwork suffers a lot. We're going to talk about it a bit later, but this is something to keep in mind. So the conclusion is that any real value from regression testing is significantly delayed. So let's talk about progressive testing now. So what are progressive tests? Progressive tests are tests which are part of definition of done of our user story. So this means that we don't close any new stories unless they're covered by automated tests. And this is the approach of progressive testing. So why does it benefit us a lot? So first of all, it enforces good design and testability from the start. This is a very important point. You may know this much more from unit testing. So if you have familiarity with unit tests, you know that just the fact of having unit tests for your code improves the design a lot. Because if you have, for example, spaghetti code with some bad architecture, you can't really mock it. You can't really write good unit tests for it. So having unit tests at the beginning, it automatically kind of improves the quality of your architecture and code because you need to be able to mock stuff, you need to be able to test stuff in isolation, etc. But what people rarely think about is that the same principle applies to any level of tests. It can be higher level tests, such as API tests or even UI tests. So if our application has some bad architecture, for example, it's a monolith, and we cannot easily test parts of it in isolation, then our test will show us that very fast, and we will be able to see that very easily. But of course, if we're going to be working on regression, we're going to find out about it too late once the application is already developed or that part is developed. So we miss out on this benefit of automated tests, which we can get very fast if we're writing tests for the stories which is currently being developed. Also, we already discussed this, but this way there's much better cooperation between developers and QAs, and any minor issue which might prevent or complicate automation, for example, some minor bug or some automation IDs are missing, this will be fixed immediately because developer is working on this and the code is very fresh, and you don't need to wait for that bug to be taken to the sprint, or you don't need to wait, or if you need to wait, it is much faster in this way. Also, it gives us, such approach gives us much more confidence in newly released features because they are considered done only when they're fully covered by automation. So we may have some technical debt already if we didn't cover regression, but at least we know that everything which goes out, the new stuff, we are much more confident in it because it's covered by automation. And any changes or any refactorings done to that part of the code, they will be much safer because it is covered by our automated tests. Also, we don't waste time trying to understand old manual test cases, which usually they're not properly written for automation. So we start writing test cases with automation in mind, and even if manual QA is involved, we cooperate with him, and these test cases would be much easier to write and convert into automation, or we just start from automation, and we don't have to go back to the QA and ask him about some old test cases. This way, we don't accumulate any new ones, which we have to take in the future anyway. Also, very important point is that this way we properly utilize the testing pyramid. So you probably have heard about it. So the testing pyramid tells us that we should cover as much as possible of our tests on the lowest level. So unit tests or integration tests, and only we should have very few tests on the highest level, which is API tests or UI tests. But of course, if we're not collaborating with developers, if we're not working on the story, which is currently being developed, so there is no real way to enforce that. So even if we wanted to cover some test cases in unit tests, developer won't be very happy if you tell him, oh, please go back to the code you've written half a year ago and add some unit tests there. So usually it doesn't work. So the testing pyramid suffers as well if we're not working on the same things. And as a side bonus, manual testers could be freed up to do some exploratory testing, or they could take part in some definition of requirements, of review of requirements, so they can find more non-trivial defects, which couldn't be found by automation anyway. So these are the benefits of progressive testing. And of course, we have to keep in mind that it's not either or. So an ideal scenario, of course, would be a balance between working on progression and regression with priority on progressive tests. But of course, maybe you don't have enough time to do both. And in this case, I would still recommend to prioritize progression with a plan to involve developers in automation tests at some point, so they can help us out. And for example, they can focus on progressive tests, and we can be covering regression. Which smoothly brings us to the next topic, which is why it's so important to involve developers in automation testing. So if you're a bit skeptical, please hang back with me. I will try to convince you, and it's possible. Actually, right now I'm in a project where we work tightly with developers, and they also write automated tests, and I will explain to you why it's so beneficial. Before we move on to that, let's discuss why it's very important to use a common programming language for both automated tests and application backend. So unfortunately, way too often I hear some arguments from test managers or some QA leads that, yeah, we're going to pick some different language for automation because, oh, it's easier to write tests in Python, or it's easier to find testers in some language, but the application backend is, for example, in .NET or in Java, and they think that this is beneficial. But unfortunately, this way you end up losing a lot of value. So first of all, developers cannot really participate in code reviews. So you cannot really share knowledge. You cannot really share experience, because usually a developer is a specialist in his own language. And for example, if you write tests in Python and developers are using .NET, you're not going to really have too much knowledge sharing. Also, this way, it's very unlikely that developers will participate in writing automated tests because they would have to learn a new language, or they would have to install different IDE, etc. We cannot really reuse any common models, packages, DB models, etc. So there's basically no code reusal this way, which can be very useful. And developers, it's very hard for developers to run tests locally. They would need to install some IDE or some environment. But basically, you want for your developers to be able to run your tests locally as easy as possible. So either for the purposes of doing some quick changes after they introduce some refactoring, not to wait for CI, for example, or you want a developer to debug your test to find out what's the root cause of the defect. And it will be much easier for him to be working within the same development environment instead of installing additional tools or additional programs. So you really make this very much harder when it's not needed. So my advice is to always pick the same programming language as the most of the developers are using. Usually this means backend, developers backend. And what are the benefits of involving developers in our tests? So first of all, developers can run tests locally. We already mentioned that. This can be done either for a quick validation or debugging. Also, this reinforces good teamwork and sharing best code practices. Especially, I would also recommend having common code reviews. So developers should also participate in code reviews of your automation code. Also, when you collaborate with developers, and developers know well your automation framework and you work together, it enforces the actual usage of the testing pyramid. So you don't overtest on a higher level. So you can, for example, from experience, if we have some user story, you want to test it, you can come up with some test cases as a QA, and then you decide together with the developer what parts can be covered on unit test level or integration test level. And only the most minimum stuff should be covered on the highest level, which you will be mostly working on. So if you collaborate closely with devs, this is actually possible. If you don't, it's very, very hard, or I would even say impossible. And also the most important thing is that developers can help you out with writing automated tests, for example, when they have capacity or when QAs are overloaded and they don't have enough time. And the issue we discussed previously of not having enough time left for both progression and regression. So this is a solution for that problem. So once you build good teamwork with developers, developers can write those progressive tests themselves because they implement the story, they know your automation framework. And of course, you will be doing code reviews, you will be doing test cases, but of course, you cannot leave this completely to the developer because he will be testing his own code. But most of the tests can be implemented by him, and you will be just doing code reviews or creating these test cases which will be implemented. So this is the approach we have in my current team, and it works very, very well. This allows us to cover everything that we need. And the ideal outcome of this would be that at some point, after you establish trust and good teamwork with the developers, the whole team should take ownership of the automation project, and the whole team should work as one and contribute to automation. And if your project gets to this place, of course, it will require building some trust, it will require some time, then the success is almost guaranteed. You can trust me on this. Okay, so we discussed why we should collaborate with developers and why we should build trust in our automation, so developers and the whole team can see the value of our automation and they would like to get involved. But in order for that to happen, first of all, we need to build trust in our automation. And in order to do that, our automation tests should be reliable. So what does it mean? So reliability means that we have consistent results. So your tests should only fail when they find actual defects or some breaking changes. So your tests shouldn't fail because of the test instability itself. And automated tests bring the most value when they are reliable and they are actually finding defects, and we don't spend any time on investigating flaky tests, etc. And our tests should run also regularly. So we always have a very quick feedback. So they usually run on CI, it may be daily, it may be after each commit. maybe after each PR. It all depends on the project, but it needs to be running regularly to bring this value. And in order for your tests to be stable, so you need to properly isolate them, and we're going to discuss this now. So in my experience, about 90% of tests being unreliable is caused by improper test isolation. So what does it mean? We're either using shared test data, which is used and modified by different tests. And for example, one test modifies this data, then another test runs, and it fails because the data is different or it's in an unexpected state. We're not using separate accounts or test environments for automation, so anyone can come in and mess up with our data, for example, in a test environment, or if you're using a shared account. We may be not properly cleaning up data after test, and we're leaving out some trash. And for example, first execution will be fine, but then once we run again, this trash will, there's some remaining data which will interfere with our tests. God forbid we rely on the order of test execution. I was hoping I shouldn't mention that, but I still sometimes see it in the project, so I have to say that, but you should never do that. Each test should run separately by itself and never rely on any other test for it to pass. Or maybe another issue with test isolation is not properly isolating APIs, for example, if we're testing microservices. And we're going to discuss this a bit later. So now let's look at the test example to illustrate this point even better. So we're going to take a look at, this is a simple test case in SpecFlow format. This is BDD format, BDD framework for .NET. So this test basically just checks the shopping cart and checkout functionality. So our scenario is as follows. So we log in, we navigate to our shopping cart, we add the product and check out in order. And the steps looks like this. So this is an example of a bad test case. So just so you know. So in a given step, we log in with some existing username. Let's say this is this user. We add an existing product to the cart. So product which is already defined in some database, like for example, Sony headphones. And we pay with 100 loyalty points. Then we check the checkout is successful. We check the total price of an order, which should match. And we check the user order history, and we check that he has one order with such title. But what's wrong with this test? So there are a few considerations you can ponder. So what changes the price of the headphones? So we've taken an existing product, and anyone can go into the DB, he can change the price. Of course, the test will fail. What if another test creates an order for the same user? Then we're not gonna have one order in the order history. What if in configuration someone disables payment with loyalty points for a given user? What if loyalty points conversion in the system is changed? So 100 loyalty points will not be $100, and etc. And even the simplest case, what if the same test is run twice? Will it pass again? It will not, because the order history will have more than one order, because we didn't clean anything here. So let's discuss how we can improve this and make this test much more stable and isolated. So for proper test isolation, we should always create unique test data, even when you think you don't need it. Err on the side of caution and create everything uniquely. So you should use unique accounts, and unique users for automation. You should never use any existing entities in the DB if it's possible, and usually most of the time it's possible. You should always create a unique set of data for each test. If the tests rely on some kind of configuration, don't expect it to be there. Inject it at runtime before test is run. And of course, you should always aim to clean up your data. So you can either clean the whole DB, you can clean up data by IDs, you can do some rollbacks. There are multiple possibilities, but you need to take this into account. Make sure your data is also properly cleaned. So let's go back to this same test and see how it would look like with proper test isolation. So first of all, before the test, we would create a username. Like we can take it from the pool of automation users, so we can create using a random string. It doesn't matter, but we create a specific user for automation, which will not be used by any other test and by any other person. We also create a product for our test. And before the test, we set up our user. We make sure he has enough loyalty points balance so he can pay. We also set up our product with expected price. We set up the loyalty points conversion, which we need for our tests. and we enable this loyalty points paintment. The actual test would look pretty much the same, but the data which we use, it will be isolated. So this way, it will never fail due to issues we discussed previously. And also after the test run, we should clean up our user and we should clean up our products to bring back our database to the known state and not to leave any other trash which may interfere with other tests. This is an example of test isolation on a simple, very simple scenario. Also, let's talk a bit about service virtualization. So this is another way you should, on a more higher level, you should think about test isolation. So especially if you have some microservices architecture, or not even, you don't need to have that, but especially in that, you should aim to test your APIs in isolation. So all external dependencies of the service or the application, it should be mocked. So why to do that? Because if you rely on, if you're testing, for example, only one part of application, but you rely on many other parts which may be changed, or you may not have full control over them, or they may call some external APIs, etc. Or even if you have control over them, you would require a very complex setup. For example, you have some, let's say you have some payment system, and your application uses it, and you need to make sure that it has sufficient balance, it properly calls this payment system, and it turns out it will be a very complex setup. So what you should do, you should use a technique which is called service virtualization. So for most of your tests, most of your dependencies, which are external to the actual component you're testing, you should virtualize them. That means basically creating mocks, which we fully control from the tests. And for example, if we take the example of this payment service, we can just say, for this test, I want this payment service to return success. So once we call it, we want to return success. And that's enough for our test. And this way, we always make sure that the service, dependent service, responds as we want it to. And there's no unexpected issues like credit balance being invalid or this service being unavailable, etc. And of course, at some point, you would want to test this integration, but this would be actual integration tests and tests designed specifically for integration. But any business logic inside your component, most of the tests should be isolated like this. And there are a lot of free and ready-to-use tools available for this. For example, WireMock, it works both for Java and .NET. I'm sure there are alternatives for other platforms, but this is an approach which will turn out to be very useful for you, once, especially if you test some APIs, but not only. And one cool bonus thing is called test containers. I won't go into too much detail to explain it. You can just write it down and Google it later if you want. But this is something we've recently started using. And this is basically a library which allows us to have any dependencies our tests need as a Docker containers. And the tests themselves set them up and then they throw them away. So on a simple example, for example, if your application uses some database or it uses some messaging transport system, such as RabbitMQ, what usually you would have to do, you would have to install this SQL server locally, you would have to install this RabbitMQ, for example, locally, you have to maintain it, and basically the setup of tests will take a long time. So for someone to run your tests, he would need to basically install the whole system on the local machine. And what this technology allows you to do is for most popular dependencies, such as SQL databases, Selenium web browsers, message transports, etc., it allows you the tests themselves, set them up in Docker, use them, and then throw them away. So basically, what we have right now in the project to run our tests, what only thing you need to have is have Docker desktop. You just click run tests. The tests are running. They set up the whole environment for themselves, and then they clean it up. So this is something to look at. It can be used both for integration or API tests or UI tests, but I won't go into too much detail because it would be out of scope of this presentation, but I thought it was worth mentioning it. It's a pretty cool technology, which was kind of recently introduced. Okay. And of course, as I've already mentioned, unfortunately, I have to say this, you should never rely on order of test execution. Each test should be completely isolated. And a good way how you can check whether your tests are properly isolated is to run them in parallel. and they should still pass. So if you're not very sure how good your test isolation is, just turn on parallel execution. Actually, you should turn it on anyway, but if you don't have it turned on yet, just do it and it will show you pretty quickly what are the dependencies between tests which you haven't thought of. And this is a good way to check that. But yeah, you should never rely on the order of test execution. That should be ingrained in your memory forever. Okay, and last thing we should mention is that using a separate test environment is beneficial for your automation. So in an ideal scenario, you should have a dedicated environment just for test automation. So no manual QAs or some other people are gonna mess up with your test data. But even let's say it's not possible, you have some cost restrictions or environment restrictions, etc., and you cannot get the separate test environment. Even then, if you apply all those principles we discussed before of proper test isolation and creating test data specifically for your tests, you shouldn't really have a problem because your tests will be using only their own data and they should be quite stable. But of course, if you can, if you have enough, your project has enough budget or has enough environments or virtual machines, you should always aim to use a separate test environment for automation. But as I've said, even if it's not possible, don't be upset. Applying other principles should mitigate that risk. Okay, so now we know how to make our tests stable, and our tests are passing. They're quite stable. We like them. But let's discuss why we should keep them passing. So why it's so important to keep the pipeline green always. The reason why you should do that is that reliable tests, they help tremendously to build trust in automation. And they should only fail on actual defects or breaking changes, not test instability. And if your tests are not failing on actual defects or breaking changes, and your pipeline is read very often, so basically the tests are failing, but they don't bring any value, they don't bring in any new defects, they don't point to any changes which were introduced. At some point, people are just gonna stop checking it because, you know, I've heard it way too often. Oh, it's failing anyway. It wasn't my change. It was failing before. One thing, people are losing trust. So automation as a thing which can quickly give us feedback, it loses value very quickly because people stop looking into it very often. Also, it gets hard to really find out what broke those tests because if you have several red pipelines in a row, you don't really know which change caused it because it just started failing some time ago. And basically, the whole idea of automation, it starts making much less sense because it stops bringing you very fast feedback and people are not trusting it and they do not use it properly. So in summary, if your pipeline is failing and there are no new defects or breaking changes introduced, it's not a very good sign and you should really take it seriously and try to make it green as fast as possible. Of course, it should fail on actual defects and changes, but not for any other reasons. If the pipeline actually fails, I wouldn't suggest to rely on debugging only. So let's say we have a failing test. Maybe it's for a valid reason. Usually what happens is that people see the test failing on a pipeline and they go and they just start reproducing it locally. So they just start running the test locally and debug it and try to fix it. So what's the problem with only debugging? The problem is that not all issues are easily reproducible in a local environment. So probably most of you have encountered this. So test is failing in some test environment, but locally it's not failing. And also another important thing is that after the debugging session, all knowledge is lost. So you did this debugging, but then the test will fail again in the future. Some other person has to sit down and do exactly the same. And basically, each time this knowledge is lost. So of course, you should debug, but you shouldn't only debug. So what should you do? You should invest in good error reporting. So this is either writing very good assertions, which are very detailed, and actually, this means that you should add more logging in code, especially after some test has failed. So a good rule of thumb I try to use is that if a test has failed for example, on a pipeline, and you cannot really easily see what was the reason. For example, there was some simple assertion which doesn't tell you much, or something happened but it wasn't in the logs. So when I go back and try to fix it, I would think what was missing for me, what kind of logging was missing, so I wouldn't have to go back and debug it, right? So this is the good rule of thumb you should use. So not only debug it, but while you're fixing and debugging this test, you need to adjust the assertions, or you need to add some logging in some places, which will make sure that next time this happens, you either won't have to debug, or the person who will do this debugging, he will do it much quicker because he will see in logs what's wrong and he'll know where to look, etc. This is a good rule of thumb I would recommend everyone using. And let's look at an example of good versus bad assertions. So the bad assertion usually is a simple assertion which doesn't really tell you much. It's just this should be equal that. It may seem that it's obvious, but very often it's not. And the next person who will look at it, it will not be so obvious. So an example of a bad assertion will be order type should be order type loyalty points. And that's it. A good assertion should be detailed. So for example, you say for a loyalty points order, a price should be displayed in loyalty points. And also a thing I like to do is to try to output an assertion some things which will help you to investigate this test. So for example, what this does is it will output the order details in our assertion, inside our assertion. So once it fails, we don't only get the information that loyalty points don't match, we have the whole order displayed, and we can see maybe this was the reason why the test has failed. So try to include as much information into the assertion as possible. Basically, add anything that can help you with investigation later. So of course, this is a simple example, theoretical one, but you should probably have intuition what you should add for your tests, for your assertions, I mean. And another thing is to add good logging in code. So this is quite self-explanatory, but I would like to show you an example of logging we have in our current project. So we have added after step. This is basically a spec flow hook, which wraps our test failures. And what this means, basically, after the test is failed, we don't only output assertions, like even if our assertions are good, we also, in this step, we go into the database and we get all the event logs and messages for a given ID. So for example, we have a correlation ID for a given test, or you can have an ID for an order or for customer, whatever. And when the test is failing, additionally to the exception or the assertion which happened, you also output all the logs from the DB. So you don't have to go manually to the DB and check all these logs, etc. It will be outputted in your pipeline. And also, if you've been paying attention, you should clean up your data after your test. So once your test is done, most of this data will be cleaned up. So even if you wanted to, you wouldn't be able to go and see what is wrong there. So it's an example of good logging is, for example, outputting this data in the actual test logs, so you can easily access that in the pipeline. Of course, this is just one example of such principle, but I hope you get the point that anywhere you can, you should add as much logging as possible. It will make checking your tests much faster and more pleasant process. Okay, and one more thing. So we discussed logging and assertions, but let's say your test is failing due to a known defect. So for example, there's an actual defect, you have found it, you have reported it, and you just leave the test failing and you say, okay, this test is failing to this defect. I will just leave it until it's fixed. Of course, it's not a good approach. You should never, because we already discussed that the pipeline should be kept green constantly. And if it's failing, it's something new. It should be something new, and it should be a signal for the whole team that something is wrong, not like that it's a known issue. It should always signal something new. And that's why you shouldn't let this test just fail. But also what I see people are doing, they're just ignoring these tests, and they just put an ignore attribute and they forget about this test. This is not optimal as well. And the reason is you shouldn't just blindly ignore your tests, because usually you forget about this test after some point, and you may forget to go back to it. And even this defect was already fixed, but you forgot to uncomment your test or unignore it, and it just doesn't execute for some time. So there are already some existing solutions for integration with your issue tracking software, for example, Jira. You can write this yourself. It's quite easy to use some, for example, Jira API or some Rally API or Azure DevOps API. But there are also some existing solutions. So this is an example of PyTest Jira, which just allows you to provide a defect number or ticket ID on your test attribute. And what it does, it will automatically connect to Jira during test execution. It will check the status of this defect. And only when this defect is solved, it can be closed or resolved, or you can define the status. Then we start running this test. And this way, you don't have to keep in mind all those tests which are ignored. This will automatically take care of it for you. And of course, if such solution is not available for your particular language or issue tracking software you use, you can always write it yourself. Most of the time, I did write it myself. It's quite easy. You just call an API and you use some dynamic vanilla, and that's it. Okay, so we have our tests which are stable, which are running on the pipeline. Our tests are green, are reliable, etc. But at some point, we notice that they're getting too slow. So it's either there are too many of them, or the number basically of tests just keeps growing and it's getting too long. So for example, it takes a couple of hours or whatever, and we need to start thinking about speeding up our tests. So let's discuss what we can do. So first of all, before we dive into anything else, this is something which you should consider first of all, is you shouldn't overtest. So unfortunately, a lot of times when I see that tests are way too slow or they're taking too much time, it's not per se the issue, some technical issue or issue with the test. It's a problem that there are too many tests on the high level where it's not needed. So we already mentioned this before, but make sure you utilize this testing pyramid and keep the number of test cases on the highest level as low as possible and try to offload those test cases to the lowest level. And before you do anything else, that's what you should first pay attention to. Maybe it's not an issue with the tests themselves, maybe it's an issue with your approach. So you should limit the amount of tests you do on the highest level. This is the first thing I would always keep in mind. And unfortunately, I've seen way too many times when some very specific business logic, some complicated logic is tested on the highest level, when business logic should be tested as low as possible. And the highest level of tests should mostly test integration of some basic flows. So this is the first thing you should pay attention to. But let's say you don't overtest, you correctly write minimal amount of tests on the highest level, but there's still a lot of tests because your application is very complex and there's a lot of things to test. So what should you do? So first of all, I would always advise in every case to enable parallelization from the start. Of course, if your application supports it, but in the modern world, all applications should support concurrent users or concurrent requests. So I'll be very surprised if your application doesn't allow it. But still, what I notice is that people, they try to wait till the very latest moment to enable parallelization, and they wait until they have way too many tests, and then they start thinking about parallelizing them. And then it is a bit too late. I mean, it's never too late, but it's not optimal to start there. And I will explain to you why. So first of all, you should always enable parallelization from the start. And what I usually like to say is that the time you want to enable parallelization is when you have two tests. So once you have second test, just enable parallelization immediately. This will save you a lot of time in the future. Obviously, it will make your tests run faster. But also another side effect, it will enforce proper test isolation early. So you will very quickly see that if something fails when it's running in parallel, but it doesn't fail when it's run sequentially, you have some hidden dependencies between your tests which you didn't notice before. And this will allow you to see that very, very quickly before you have a huge number of tests which you need to refactor. And also another very important point is that if you wait too long to do this, you may find those issues with parallelization, but you already have a huge suite of tests, and you may need to do a lot of refactoring. And that refactoring could be avoided if you just started from the very beginning. And that way you wouldn't be writing tests which wouldn't be working in parallel, and you would already know very quickly if there are some issues. So if you still don't have parallelization enabled, please do enable it as fast as possible, because you will run into a time when you will need to speed up your tests anyway, and the earlier you enable this, the less you have to refactor later. And you should probably start with the basic built-in TestRunner Parallelization. So this would be like a JUnit or NUnit, depending on which test framework you use. But usually most frameworks allow it very easily. So for example, to very easily do this, for example, in NUnit, all you need to do is either on the test or on the assembly, just put a parallelizable attribute, and you can limit the scope of this parallelization, so you can run only fixtures in parallel or every test in parallel. It depends on your solution. But basically, this is a very simple way to start. You don't need to have anything else. You don't need to basically set up any environments for this. Just plain old TestRunner parallelization. And the benefits of this is that it's the easiest to set up, of course, and you don't need any additional infrastructure. So basically, just set it up, and that's all. But of course, there are also drawbacks. So this kind of parallelization is only limited to a number of CPU threads on your machine. So the most I've seen people were able to run tests in parallel on their local machine. It was like 16, the same on the pipeline. So about 16 tests in parallel. That's a pretty good number. It should be quite enough for most cases, but it's not very scalable. So as I've already mentioned, you're limited to your CPU. So if you have a very huge project where you need to test for multiple devices, for multiple operating systems, multiple browsers, etc., and the number of tests is really huge, this approach won't be enough for you because basically you are limited to your CPU. So in that case, you should. There are some solutions which you can use. For example, for UI tests, there is Selenium Grid, which allows you to offload your tests to different nodes on which each of them runs on different, for example, nodes or virtual machines. You also have Selenoid, which is the same idea, but implemented in Docker containers. You don't have to use this. You can even configure it yourself, but probably you should use some already existing solution, basically, which will split your tests and run them on different machines or virtual machines, etc. So this is an option which you can use when you need to really run a lot of tests in parallel. And one more thing we can do to speed up our tests, in this case, UI tests. So this is something I don't see too often, and it's really disappointing. So you should utilize APIs as much as possible in your UI tests. And what does it mean? That means that you don't need to execute all actions in user interface, which is, of course, very slow, if the test is not specifically validating that thing you're trying to test. So in order for you to illustrate this point, we can look at the example of our test, which we discussed before, which is the shopping cart test for a checkout. So in this example, what we're testing, we're actually testing only checkout. So the steps after them, we verify that the checkout is successful. We verify the total price of an order and the order history. And this is what we need to verify in UI if we are writing actually UI tests for this. But the login, and for example, adding a product to a cart, it is probably already validated by some other tests. For example, we should ideally have some login tests. We should have some tests for the exclusively adding a product, etc. So we don't need to repeat that in UI because it's already tested at some other test. And it takes some time because you need to open a browser, you need to log in using a mouse, even if it's a virtual mouse. It's faster than a human, but it's not as fast as an API. So what you should try to do in your tests, only validate things you need to in your UI, but try to utilize API as much as possible. For example, these steps can be automated using an API. And of course, this assumes that we have this functionality tested in some other test, which uses UI. And by taking this approach, you can really speed up your tests and make sure that you use the slow UI only when you need to, and not for each step of the test when it's not needed. And of course, never use thread sleep. So this is also should be pretty obvious, but unfortunately, I still have to say that because I still see it in the projects. You should always wait for something to happen. You should never rely on static sleep or static waits. For example, if you need to wait for some action or wait for login, wait for some element to appear, write down such methods yourself or use, for example, Selenium waits for that, but never just put blind thread sleeps in your tests, which wait for a specific amount of time, no matter what. Because even if it's like 3 seconds, but it's 3 seconds and you have 300 tests, and actually this element usually appears after 1 second or 2 seconds, it's like 600 extra seconds which you waste, and it's not a good thing to do, just in general. So you should always try to wait for something instead of using thread sleep. Okay, so that is all for now. So thank you for your attention. Just to conclude, we discussed today the importance of involving developers into your automation project. We also talked about how we should pick something for automation, how we should decide where to start from. We also discussed why it's important to have our tests stable, why it's important to keep our pipeline always green, why it's very important to invest in good logging instead of just debugging. Also, we discussed proper test isolation, and we also discussed how to speed up our tests. So I hope it was useful for you. And if you have any questions, please write them down in the chat. I will reply to them. And here you can check our career opportunities and leave your feedback if you scan these QRs below. So for the questions, I'm ready to take questions, and please, you can write them in the chat, or you can unmute yourself and ask them.
Yeah, let us encourage people to ask some questions, guys. So we are sure that you have some. Don't be shy. All the questions will be covered. And I have the question from our internal chat. Actually, one is, or few are here, so I will pass them till later. So please, Vlad, can you answer these two questions we have here?
Yeah. Okay. So first question is how to make progressive testing approach applicable for long-term projects. For this approach, they always should be at the same point as developers are, but automation testers could do not only automation, they also need to maintain the framework, investigate issues, and refactor tests if functionality changed. Yes, that's a good question, but that's why we discussed at length the collaboration between developers and testers. So in my experience, developers are helping us out. So if as a whole team, we decide that we don't close stories without the automation test, it's decided like by our definition of done, even if developers are freed up, but we didn't close some stories yet, they're going to join and they're going to help us close those stories. So ideally, for this approach to work, automation should be the product of the whole team, not only automation QAs. Of course, they're responsible for it, and they're like the kind of owners of it, but developers should also join in and help. And this is the only viable approach, I think, for it to really work. And that's what's going on in our current project. So once, for example, we don't have enough time to write automation tests, or development is moving too fast, developers, they jump in and they help us with automation. And that's how it's really possible. And that's, I think, the best approach, the most optimal approach to make sure that this is working for you. If you have any follow-up questions, you can also write them in the chat. So another question, what metrics would you recommend to use to prove the efficiency of automation? This is more like a question for some QA manager or metrics and stuff like this, but from myself personally, if we're not talking about some metrics, etc., like which usually test managers do, I'm not a test manager, I would we can look at the number of defects which we find. We can look at the stability of our tests. Usually, for us, what is important, we look at how stable our pipelines are and how many times issues are popping up which are not actually related to the defects or to some real changes in the code. You can also use some code coverage metrics, etc. And for example, to check how much of application we've covered, so that you can also use that. But I think this is mostly domain of some QA managers, but I hope I've at least answered it partly. Okay. Next question: how would you deal with an increasing number of automated test cases in a regression park? Yeah. So first of all, if, as I've said during the slides, we need to think: are they really justified in being so increasing so much? So I would first ask myself: aren't we over testing? Can we offload some of those tests to the lower level? Can we test them on API level? Can we test them on the unit test level? If you think that they're justified to be at the highest level, then the way you deal with them, you should, if there's a lot of them, you should start thinking about some kind of parallelization so they don't take as much time. You should pay a lot of attention to their stability, because the more tests you have, the more maintenance they require. So you should really try to make sure that focus razor sharp on the stability of your tests. And yeah, sometimes you just, if you considered all those points and those tests have to be there, then sometimes that's just reality. You have a very huge application which has a lot of tests, and if there's a lot of them, you need to make sure that they cause as less pain as possible. So they should be stable, they should be valuable. You should try to trim them down as much as possible, replace parts of it with API tests when possible, and etc., etc. So, but sometimes it's just the reality, and you have a lot of tests. Then you need to think how to get the best of it and make sure they're as stable as possible. Next question is, can we think progressive testing as TDD, test-driven development? We can kind of think of that, but I don't think it's really one-to-one mapping, because TDD, it assumes that first we write tests, usually these are unit tests, and then we write implementation based on those tests. We can think of them as TDD in a sense that you can start writing the test before the implementation is finished. That's correct. It may not pass, which is of course expected, but I wouldn't say it's really like one-to-one mapping to the TDD, because it's mostly, I think, applicable on unit test level and developers code level. But in some sense, yes, we can think about it as that. But the most important thing you should remember, the thing that defines progressive tests, is that the automated tests are part of definition done of the story. So you don't close any story without automated tests. And that's the important thing, and that's what defines progressive approach. Thank you. Thanks for the answers. Thank you for the questions. Hey, what are the top 3 asserts you use in automation tests? Is true, is false, etc. It's a cool question, but usually I don't use is true, is false. In our project, we now use fluent assertions. So I may write it in the chat so you can Google it. I'm not sure which language you use, but let me quickly find it. Basically, it allows us to write assertions in humanly readable language. So can I find an example quickly? Okay, I can't find it. But basically, the assertions look like you have something should be something, or something should equal, something should contain, etc. I mean, yeah, in C# you can. It's for C# as well, so you can use that. And usually it's should equal, or should be, or should contain. And I find it much more humanly readable than basic unit and assertions or X-unit assertions. So you might want to take a look into that. But it's not so important which assertion per se you use, either it's is true or should. You should make sure that the message you have after assertion is very detailed. And if your test fails with expected true but is false, it's not going to tell you anything. But if you, after this assertion, if you write like expected something to be true, but it was false because of this, then it's fine. Then you can use any assertion you want. The most important thing is to actually make sure they give you enough information for you. Yeah. Thank you for the question. Do I understand you correctly that on your project there are no manual test cases, only development and then automation? If yes, then what QA team is doing on your project? So the approach I discussed, it applies on the projects where there are also manual tests. But yes, currently I'm right now on a project where there are only automation QAs. So we have a microservices architecture. We also have some UI tests, but only one team is doing them. This is the operator portal. And this is possible. And basically what QA team is doing on your project. So we only recruited automation QAs, and we expect from our automation QAs both the programming skills and the skills of general QA skills, like how to construct test cases, how to make sure you cover in some acceptance criteria, etc. So our QAs are actually QAs and automation QAs. So what this allows us to do is that we start by basically each story by creating test cases for it, as a usual QA would do. We can do it in a text format or in BDD format, and then we just start implementing them. So it's either us as automated tests or developers help us, and this is how it works. So we don't really have like just manual QAs. We have professionals which are good at both, and that's how it works very well for us. Okay, no problem. Thank you too. Okay, regarding the progressive tests, first time for me finding out this approach. Do you add all the progressive tests to the regression suite? Thank you. Yes, so basically progression tests becomes regression tests once the feature is released or the sprint is done. This is not so different in the sense that you have a regression suite, but as I've said, it just becomes regression at some later point. So once you're done with it, once the story is closed, you don't implement the story anymore. It just becomes a part of a regression suite, and that is how it works. It's not much rocket science. But the main idea of the progression is that you do this test for the features which are in progress and actively developed, and you don't start from the features which are developed a long time ago or they're not currently worked on. And that's the difference. Thank you for your question. So I see there are no more questions at the moment. So if you have them, this is the last chance to ask them. If not, if there are no more questions, I thank you very much for your attention, for very interesting and exciting questions. I've already mentioned, please check our career opportunities on this QR code here, and you can leave your feedback. It's very much appreciated, your honest feedback for me, for the presentation. It helps me to improve in the future and know what you liked, what you didn't like, and what I can do better next time. So thank you very much for your attention.
Thank you so much, Vlad. That was a pleasure to listen to you, and also thanks for your deep dive into automation and sharing all the insights and your wisdom in this area. Thank you also, guys, for being with us. You can totally be proud of you spending even more than an hour for learning and upskilling in your professional way. So thanks once again. And yes, Vlad mentioned, if you would like to check our career opportunities, you are welcome for this QR code, and we will be really glad to have your feedback and improve or organize something else for you as well. So thank you so much. Have a pleasant evening. Yeah, great. Thank you. See you again at Ciklum Speakers Corner. Bye-bye.
Thank you very much.
Thank you. Bye-bye.
Bye-bye.
Thank you. Bye-bye.
Thank you. Bye.